So we said, look at binomial. We did the Pascal's triangle, the binomial theorem, and we're here to appreciate it more. We discovered that what we call the binomial theorem is actually a plus b power n, n0, an, n1, an minus 1b, n2, an minus 2b2, n3, an minus 3 b3, going up the general term br all the way up to nn bn. Now, one of the limitations that Pascal's triangle also had is you could not evaluate it easily if the power is negative. When n is negative, it will be directionless on the Pascal's triangle there. It's not that easy for you to evaluate. So what we do is, if you force the evaluation there, then you have to take everything in the denominator. That's when you can use the Pascal's triangle. But the binomial theorem doesn't care. Even if it's negative, it can operate directly. Okay. But at which point do you get to see it operate directly? Is when you're able to calculate, as agreed, we say the definition of NR is n factorial, r factorial, n minus r factorial. Okay. So we'll start with calculating n choose 0, calculating n choose 1, calculating n choose 2, and n choose 3. So n choose 0, following the definition on top, it's n factorial over 0 factorial, n minus 0 factorial. Agreed that day that 0 factorial is just 1, and that n factorial is n minus 1. Keep going. When you feel like ending, you put a factorial. So that this will become n factorial over 0 factorial is just 1. N minus 0 is n as a factorial. In mathematics, n number over itself is 1. Apart from 0, the most confused number. Then n choose 1, we say n factorial, 1 factorial. Remember, 1 factorial is just 1 by 0 factorial, which is 1. So 1 by 1 is 1. And then n minus 1 factorial, giving us the numerator there can be tempered. It can go as far as there. Stop there because we have seen something similar to it down. This n minus 1 factorial. And because in mathematics, dividing n number by itself gives us a 1. So here we just have n over 1, which is n. Okay. N choose 2, we'll have n factorial, 2 factorial, n minus 2 factorial, giving us n minus 1, n minus 2. We can stop here because we are seeing it down. 2 factorial, n minus 2 factorial. Mathematically, this guy divided by this guy, we get a 1. So we remain with n minus 1 over 2 factorial. N choose 3, n factorial, 3 factorial, n minus 3 factorial, giving us n minus 1, n minus 2, n minus 3. Once we see n minus 3 factorial on top, because we have it down, we can stop there. Mathematically, this guy into there, we get a 1, so we remain with n minus 1, n minus 2 over 3 factorial. So you can see that if you went on, the numbers would be increasing in that manner, but all application questions will end at n choose 3. We'll get what we're looking for in n application question. Now this means that we can write, should we name this 1? We can write 1 in the form a plus b power n is equal to, instead of saying n choose 0, we'll say 1. Now 1 by an is just an. Instead of saying n choose 1, we'll just say n minus 1b. Instead of saying n2, just say n minus 1 over 2 n minus 2 b2. Instead of saying n3, we'll say n minus 1 n minus 2 over 3 factorial n minus 3 b3. Okay, even more nice, if we have 1 in the position of a and a bx in the position of b, you notice that where there is a, you will have 1. 1 to the power n is still 1, plus n, where there is a is 1. 1 power n minus 1 is still 1. So we'll have multiplied by bx plus n minus 1 over 2 bx squared plus n minus 1 n minus 2 over 3 factorial bx power 3. Like that. In most application questions, when you're dealing with 3, whenever we choose to use 3, or questions that demand for the use of 3, may also ask us to find what we call the range of validity, a range of values of x for which the expansion is valid. It's always obtained in the manner of getting the dx in the modulus less than 1. So that if the third piece comes in the manner of a plus bx, all right. Let me drink water.
The 2 first seconds you can get what I don't know. سيدنا what's value the certain validity.
Okay. Don't worry, I've not missed anything in the speed. So when you're talking about the range of validity, we are talking about an expansion of in the form of 3 or a general form, say a plus bx to the power n. For which values of x would this expansion be valid, given that a and b are constants? This is where I was saying you get the modulus of bx, make it less than a, provided that a is a positive number. Remember that the modulus is never less than a negative number. So if you allow a to be negative, then you're in problems. This means that if you find a as a negative number, you must do something to make it positive without changing the expansion. So far, so good. Is it? Or there are questions?
Unless you give an example.
So let's do examples now. Example. Example 1. Expand expand 1 minus 4x to the power half up to and including the term in x3, like that. So expand 1 minus 4x to the power half up to and including the term in x3, meaning you expand all the way up to power 3. Okay, so you need to expand all the way up to power 3. So to expand all the way up to power 3, we have the solution. Now, if you look at our question, it falls in the nice category of expansion 3, where our target is just on the B part. So you would say, okay, here we are saying 1 plus n. We say n. Now our n is half. Then bx, it is negative 4x plus n minus 1 over 2 multiplied by negative 4x squared plus n minus 1, n minus 2 over 3 factorial. 3 factorial is 3 by 2 multiplied by negative 4x to the power 3. Once we reach power 3, we end there. Meaning this is 2, 1. Half multiplied by -4, we get -2x. Plus, we have half minus 1, we get -half. -4 squared, we get +16 over 2x squared plus half minus 1 is -half. Half minus 2 is -3 over 2. -4 to the power 3, we get -64 over 6. 6 is 3 by 2, x power 3. But you can see that 3 here, 1, 3 here, 2. Okay, and then 2 by 2 by 2 for this part, 2 by 2 by 2, we get 8. 8 into 16, we'll get 2. 2 by 2 by 2 by 2, we get 16. 16 into 64, we get -4. So what we have now is 1 minus 2x, 1 by 1 by 2. In fact, it will be -2x squared why are we multiplying by 3 by 2? Why are we dividing by 3 by 2? It's 3 factorial, calculated from n to 3. We got a 3 factorial in the denominator. 3 factorial is the same as, this is the same as 3 by 2 by 1 by 0 factorial, which is 3 by 2 by 1 by 1. Okay, thank you. So we get 1 minus 2x minus 2x squared, negative, negative, negative. So we have another minus. This time around is 4x power 3. So our expansion ends here. If an additional question pops up, say find the range of validity in the expansion of 1 minus 4x to the power half. The solution will be the modulus of -4x to be less than 1. Now, how do we solve this type of inequalities? The 4 can go out. In fact, initially we say -1 is less than -4x, which is less than 1. Divide by -4, divide by -4, divide by -4. We'll get that 1 over 4 is greater than x, which is greater than -1 over 4. And this is written as -1 over 4 less than x less than 1/4. We did this in inequalities. Or if you are not a good friend with inequalities, from there you just say, I'll take 4 out of the modulus as a positive number, divide by 8, divide by 8. So my solution is this guy less than that. You earn full marks if you have that. This was example 1. Questions now?
Sir,
Yes.
what does this same validity mean?
It means that if you pick any value of x that is outside the interval, the expansion won't make sense.
Oh,
Yes.
so now, sir, do we need to test when we find those values, like the ones we found there?
No.
Okay.
As long as you follow this procedure, we trust the interval that it needs no testing.
Sir,
Hello.
this is the first example from how we've started. We've just joined, so I don't know.
You just joined.
Mm.
Yeah, this is our first example from the time we started, before you joined.
So you're talking about what? What's the topic?
The topic is still binomial, and we are talking about how to use these expansions when you meet a question that requires n of them. We are saying the beautiful expansion to use is the third one. And so I wanted to appreciate its beauty by having this example that requires the third expansion. So you notice that you have less work to do when A is 1. So because of you who just joined, we'll do example 2 similar to this one, so that you don't feel to be behind. Very, very similar. Example 2. Expand -2 plus x to the power -1 up to and including the term in x3. So how do you do that expansion? So you say solution. This is -2 plus x power -1. But this guy does not look like the third expansion. It looks like the second expansion. And so we'll have issues dealing with A and B. You expand, you power -2, you also power x. We'll have a lot of work. So what we do is we make it be in the form of 3. So we factor out -2 and have 1 minus x over 2. The power is -1. But from indices, if you have A, B to the power n, it's okay to separate the two by giving them each the same power. So that here we have -2 power -1 multiplied by 1 minus x over 2 to the power -1. Now we also understand that if you have x to the power -1, in most cases we write it as 1 over x. So that this guy becomes 1 over -2 multiplied by 1 minus x over 2 to the power -1. Now, when that is the case, then we'll have -1 over 2. Now we do the expansion. So the power is -1. So we have 1 plus our -1, the n. We are following this format here, where I just substitute where there is n and where there is bx. The other part is just following because it's a 1, 1, 1, 1. So our bx is -x over 2 plus -1, -1 minus 1 over 2. Bx squared is -x over 2 squared plus -1, -1 minus 1, -1 minus 2 over 3 factorial. We said is just 3 by 2 by 1, -x over 2 power 3. So that we get -1 over 2, then 1, negative by negative, we get plus x over 2. And then you notice that on top here, we have -1, we have -2 over 2, and then we have 1 over 4 x squared. 1 over 4 is coming from -x over 2. Now the over 2, when you square it, it becomes over 4. The negative, when you square it, becomes positive. Plus -1, -2, -3 over 3 by 2 by 1, and -1 over 8. When you cube the over 2, it will become the over 8. But this is just -half outside. 1 plus x over 2. This 2 in that 2, negative by negative, positive, so we remain with 1. Hello?
Sir, please, just a minute or a second.
Hello? Hello?
Sir, you're too fast. Sir. I'm still on this one, looking at this one, the one before.
Okay. Then here, if you look at 3, can go in 3, 2 can go in 2, 1, if there is need, it can go in 1. Then you have this negative. By this negative, you get positive. This negative, by this negative, we get positive. Hello?
I am behind.
Where?
From the second one. Okay, just restart. So I haven't did anything.
Mm-mm. Okay, don't worry. So let's put the last statement and then I'll explain. So if you multiply the four negatives, if you multiply the four negatives, you get positive, and then you have 1/8 x to the power 3 and the expansion ends here. So the key thing is we always want to assimilate. So we want this thing here to look like the easiest expansion that we have, expansion number 3, where our first term is 1 plus the other part. We don't care what the other part becomes, for as long as the first term is 1. It becomes easy for us to expand because just substituting the second part and the n. But how do you force a 1 if you have a -2 there? You factor out a -2. And since they're all in the same power, when you factor out, you split them using this property here. So you split -2 to the power -1, whatever remains in there to power -1. But anything to power -1 is just 1 over that thing. So we have 1 over -2. And then you get the expansion now. Once your first position is 1, in the third expansion here, you concentrate on the b part and the n. Substitute n multiplied by bx, n -1/2 by bx squared, n -1, n -2 over 3 factorial by the b part to the power 3. So that we now have this as our b part, the whole -x/2, and our n is -1. So you substitute -1 for n, -x/2 for b. -1, -1 minus 1, this is for n -1. And then the b part squared over 2. And then the n, n1, n -2 over 3 factorial. And then the b part cube. Then now you simplify. So this gives us a positive. These are just adding -1, -1 minus 1, -2. -1, -1 minus 1, -2. -1 minus 2, -3. -1/2 to the power 3 becomes -1/8 x power 3. And then you simplify now this to this 4. That's the expansion. So I'm saying in case they ask for the range of validity, you will say, so you pick this part here and say, okay, the modulus of -x/2 should be less than the a part, which is 1. But this is the same as -1 less than -x/2 less than 1. Multiply throughout by -2, you get +2 greater than x greater than -2. This can be written as -2 less than x less than 2. Why are we putting 1 in place of x? Which one in place of x? Linda. Okay, so the Zoom will be cutting 10 seconds from now. So you just rejoin when it cuts and come back. We'll be starting shortly. By 41, we would have started already. So don't come late.